Okay, so you guys will see that I went ahead and I wrote down explosion. I didn't have enough space on this side for this main idea of this paragraph. I can tell that we're about to start a new main idea because it even has its own text feature, which I just boxed. Our sun won't blow up. Our sun, we know, is a star, and there it won't have that supernova explosion kind of situation going on. All right, so I already know that this is a new main idea I'm about to read. I went ahead and I coded some of this. Supernovae are violent. That's a tone mode feeling word. It has a negative feeling. I also put my little negative sign. When it says supernovae are violent, it definitely reminds me of when it said, or supernova is the spectacular death of the star. Spectacular meaning a big deal, the same way that this was written in the title, kind of bigger and brighter. They use the word violent. That's a pretty big deal as well. So it's one of those high energy, more intense tone mood feelings for a word. Supernovae are violent, but we do not have to worry. Reminds me of the sun will not blow up. The sun will never explode. If a supernova occurred, that means happened within a few dozen light years of Earth, we would be in trouble. But the nearest star that will explode is more than 100 light years away. All that extra stuff. This is basically telling me that the sun will not explode. Okay. Just make sure you guys can see. Yes. All right. It says, or it continues, believe it or not, supernovae help life. Help. In fact, without them, Earth would not exist. Neither would we. So it tells me we need supernovae in order to even exist. If not for that, we would not exist. So that tells me how it helps us. Okay, so I wrote down for this one, supernovae help. I'm even gonna add we need. It states right here, here's why. That already tells me that this is gonna be the same main idea continuing down here. Here's why. Here's why what? Here's why we wouldn't exist without the help of supernovae. When the universe began, it only had the three lightest elements, hydrogen, helium, and a little lithium, but life needs heavier elements. Needs. Ooh, there's that key word again telling us about this new main idea. How supernovae helps us, how we need it. We need heavier elements, such as oxygen, which we breathe, need to breathe to live, and iron, which is in our blood. We need iron in our blood. No iron, our blood would just not help us survive. Our blood would be pointless without iron. And Earth is made mostly of oxygen, silicon, and iron. Most of all, oxygen came from massive stars like Antares. That word gets me each time. During their lives, massive stars cause helium nuclei to join together to make oxygen. All this is kind of like a bunch of fluff. It's just telling us how stuff is going down here and how we need it. Already told us that we need it. They're just going into more detail. Then when the stars explode, supernovae, we already know that this is supernovae, or supernova for one star exploding, they cast this oxygen into space. So it sends out oxygen into space. And the explosions themselves, the supernova themselves, or the supernovae, make iron, remember, which we need. Again, helps us, we need it, same main idea. In fact, scientists think supernova explosions made most of the iron in the universe. Okay, in the universe. Let's not forget our captions. A star needs fuel to make the energy that fights the pull of gravity. Remember how we learned about those two forces at work going on? Once the star uses up its fuel, gravity wins the fight. The star's center collapses and its outer layer blasts out into space. The star becomes a supernova. Cool. All right. So, take a quick look at how the way that this built up again. What a supernova, from size, or what is it? Where is it from? Energy, how it makes energy. It continues on the next page to how it makes energy. I'm just giving you a quick look again to make sure you have these notes down. New idea, okay? The author defines light years. Continuing with a similar idea. How the star expands. How the star makes energy. The red supergiant specifically. Again, this one was about how a massive star must make lots of energy. So still going on with that idea of energy. Okay. I can tell that energy is going to end up being one of our questions. Right. Same idea again. Energy again. That fight between the star's energy and the gravity trying to make it collapse. An explosion is caused. What's that explosion called again? Supernova. Okay. New idea again. Our sun won't blow up. Our sun will not explode even though it's a star. We won't get supernova out of it. So, it says it will never explode. All right. But it says now that we need supernova. It's helped us in life. It made us exist in the first place. Why do we need it? Based on the text. We need it because of the elements caused by a supernova, specifically iron and oxygen. Okay, we breathe oxygen, iron's in our blood. So again, need. All right. To dip into these, so I know that that one was a little bit tough on many of you, as you said today over Zoom. Let's see now if you guys got those answers right. I'm gonna breeze through these a little bit faster than I did that article, because as I wanted to go deep into the article, guys, because when you guys get an article like that on an FSA test, it's gonna be paired up. 6th grade and beyond is going to be paired up with a few more texts, and you're going to get way more than 2 questions, or technically 3, with your part A, part B thing going on. Okay, so this question has 2 parts. First, answer part A, then answer part B. We usually know that part A is asking you about an idea, and part B usually tells you about evidence to support that idea from part A. All right. So you first think part A, then you see what evidence is going to connect. What are 2 main ideas? That's what our standard is asking. That's what we've been building up over the week, or building up to over the week. What are 2 main ideas of this article by Ken Crosswell? I also told you guys that in many FSA questions, they use the author's name to try and trick you. Supernovae are violent explosions of stars. Remember that word? That was a big deal of a word. Violent explosion of stars. Astronomers did not always use telescopes. Topic here is telescopes. Astronomers can see supernovae for months. They did tell us about seeing supernovae and how you can see it, but they only dipped into that for a little while in the 2nd paragraph. Or I think actually I'm lying, it was the 1st paragraph. We only talked about seeing it one time. Stars make energy through nuclear reactions. Make energy. We just finished talking about how much the author talked about making energy. So right away, you should have done that too. Put your little swirl. Stars produce light that travels across the universe. Okay, I don't know that much about that. Supernovae are interesting for astronomers to study. Nah. All right. Go ahead and pause this if you haven't done this one yet. pause the video for a moment and get your other swirl. Remember, 2 main ideas. I've still seen throughout the year that some of you had only chose one when they clearly ask you for 2 answers from these answer choices. So go ahead, pause me, find your 2 answers. All right. Violent explosion of stars. You should have swirled this one. They talked a lot about the explosion and they at least built up to it between these 2 ideas. That fight between energy, the gravity and the energy that the star tried to make, and eventually after several light years, poof, there's an explosion. I know it wouldn't make the sound poof. That's ridiculous. Astronomers did not always use telescopes. Who cares? That was only mentioned a little while, or a little bit in the beginning. Astronomers can see supernovae for a month. That was talked about. Again, telescopes, and this one, both of these answer choices are all about seeing. Who cares? Once again, fluff. Stars produce light that travels across the universe. Okay. And supernovae are interesting for astronomers to study. That's nice. It's not a main idea. So you should have gotten A and D. Part B, remember what we said. Part A is all about an idea. Part B is all about evidence. I'm going to read these. You should have already found what paragraphs they are from. If not, I'm going to help you breeze through this a little bit. Which 2 sentences from the article best support? So remember, one is about main idea. This one is about supporting details, just like your standard says. 2. Okay. As soon as I read this, I should go back to part A to read these 2. Which 2 of these support this? I'm reading this again to cement it in my mind. I just read all this other rubbish. I want to cement these 2 in my mind. A, supernovae are violent explosions of stars. Okay. D, stars make energy through nuclear reactions. Okay. The last time people saw a supernova in our galaxy was 1604. I already know that you know that one is not it. I'm just going to tell you the paragraph. That was before astronomers were using telescopes. That one's also in paragraph 1. Such a star is born with more than 8 times the mass of the sun. Paragraph 2. Its center makes energy the same way the sun does, by changing hydrogen, the lightest element, into helium, the second lightest element. That one is, I believe that was in paragraph 3. E. As a result, we can easily see the star across hundreds of light years of space. That one is from paragraph 5. And this last one is from paragraph 9. If a supernova occurred within a few dozen light years of Earth, we would be in trouble. Again, paragraph 9. If you haven't done this homework yet, pause me now. I want you to code this up real quick. Okay, I'm going to go ahead and code it. This one's about people seeing, right? That goes with one of these. This was about using telescopes to see, people seeing. We know those 2 are wrong. That was before astronomers were using telescopes. Again, very nice. Who cares? Such a star is born with more than 8 times the mass. This is about size. 8 times the mass of the sun. D, its center makes energy the same way. Ooh, makes energy. That was a big deal. As a result, we can easily see the star across... see the star. Again, that's what this one's about. Remember, was seeing it a main idea here? Not so much. Tricks all over the place. If a supernova occurred within a few dozen light years of Earth, we would be in trouble. Tom would feel in trouble. A few dozen light years of Earth. And that's if that were to happen. Okay, pause me again. Look in the text and decide which ones are the 2 best key details. Some of these might be key details. You might have more than 2 supporting details, but it's all about, do these 2 details support A and D? Pause me and go get your answer. Okay. So again, A talks about what people are seeing, so that went along with our unimportant ones about seeing. So that one, wrong. That was before astronomers were using the telescope. Again, who cares about whether they can see it or not and how they were seeing it? This one, wrong. Such a star is born with more than 8 times the mass of the sun. Are we supposed to care that much about the mass? I know it talks about how massive they are, but was that the main idea? Not so much. I could see why some of you would have chosen this one, because it talked so much about how massive they are and about the star giant and all of those. But this one was your trick. Okay, but it is not C. This one's about making energy. It talks so much about making energy. If you were to go back in the text, paragraph 3, paragraph 4, paragraph 5, and then back to paragraph 7, paragraph 6, all that talks about energy and that whole build up towards the explosion. Okay, so one of your answers was D. Which one does it support? Does it support supernovae or violent explosions, or stars make energy through nuclear reactions? Oh, look, makes energy, make energy. Okay. Bloop. As a result, we can easily see the star across hundreds of light years of space. That's nice, but what does that relate to again? Seeing the star. Was that important for us to see the stars and for astronomers to see the stars? Yeah, but no, not for the main idea. If a supernova occurred or happened within a few dozen light years of Earth, we would be in trouble. This one doesn't sound like a key detail. It sounds like fluff because the author uses a tone, mood, feeling word about being in trouble, and it sounds like, nah, that's not important. But look at this one. Supernovae are violent explosions. The whole text was about, or leading up to telling us about the explosion of these stars. The author uses the word violent. The author talks about how if the supernova were to occur a little bit closer to Earth, we would be in trouble. Yes, we needed it to happen for us to exist in the first place, but we don't need that again. So it would be F, which relates back to A. I already told you that since so much of the text talks about energy, the author and the test maker will give us some kind of question that deals with energy. But as long as a star can make energy, it can fight the force of gravity and survive. Which dictionary entry, that means which definition in a dictionary, best defines energy? And you should also add to this question in your own head, which one best relates to the meaning of energy as used in this text? This is our DSV standard. Okay, is it talking about physical strength, hydrogen and helium gas, heavy metals that increase weight, power that comes from heat? Which one is most related to energy as used in the text? Pause me and look for your answer and decide on it. Pause. Okay. Is it about physical strength? These two elements in its gas? Weight? Or power that comes from heat? You should have chosen power that comes from heat. It even says right there on the first page when the author starts talking about making energy. What did the author say? This nuclear reaction, when hydrogen changes into helium, that's where they tricked you, creates energy that heats the star and makes it shine. There you go. The author kind of hid that information right in there. All right, so you should have answers A, D, D, F, and D. Cool beans and rice. Okay, so for this one, you can go ahead and pause me and work on this one. I know that the structure of it looks a little bit funky. You're going to read these PMIs, read these possible main ideas. It doesn't mean that these are the main ideas of the text, but they are ideas within this text. And this is the way, even though it's not a main idea, test makers will do this to us. They will choose these weird random ideas that the author may not have talked about a whole lot, and they will ask us questions on that to throw us off. So think about it. What did the author choose as a main idea to talk about? These are all possible main ideas. In 1604, a supernova exploded. Supernovae make important elements. Astronomers did not always use telescopes. Right away, we know this one is not it. It's annoying. Antares is, I said it right, is a massive star. Only some stars will be supernovae. Hydrogen is the lightest element. Okay, y'all. Which one? Go ahead and pause me. And you're going to choose, remember what this says, 2 sentences that are actually main ideas of that text. Go ahead and pause me, choose your 2 main ideas. I mean, it's up to you whether you're going to pause me or not, but if you just wait for the answer, you're not going to learn anything. Don't think I can't see you. I'm just kidding, I can't see you. That's creepy. Okay. In 1604, a supernovae exploded. Yo, that's like a fun fact. It's not a whole big idea. It's going to throw you off with the word exploded if that's one that you chose. Supernovae make important elements. Okay. This talks about supernovae makes elements. Okay. It talked about it in the beginning of the text about how it changes from one element to the next, or changes hydrogen into helium, and this nuclear reaction is what creates the energy that kind of keeps that star fueled. Talks later on again about changing helium and other elements into heavier elements to make energy, even though it might not make as much energy with star giants. And then later on again talks about how these elements helped our existence, or caused our existence rather. All right, so astronomers did not always use telescopes. Antares is a massive star. Only some stars will become supernovae. Hydrogen is the lightest element. Okay. If you didn't choose, go ahead. I'm about to highlight the answers. Go ahead and pause it. Give yourself a high five in the brain if you got it right. So, down here is where you're going to write the answer to which 2 of these. So, main idea 1, main idea 2. So, the 2 of these that are right, you're going to write one of them down right here in this box. You're going to write the other main idea down in this box. Supernovae make important elements. That's one of your answers. And then this one was a little bit of a trick. Only some stars become supernovae. Remember, the author dedicated a whole section, a whole new main idea to how, even though supernovae are violent, the sun, which is a star, will never explode. If it doesn't explode, that means that it's not what? Supernovae. Or a supernova, sorry. All right, so you should have these 2. All right, let's choose now for each one. I'm going to go ahead and label this main idea 1, main idea 2, Choose one detail that best supports each main idea. One detail for main idea 1, one detail for main idea 2. The last time people saw a supernova in our galaxy was 1604. Oh my gosh, they're still with it. However, every year astronomers see supernovae exploding in other galaxies. The sun will never explode. And the explosions themselves produce iron. The outflow of huge amounts of energy, much of it light, pushes outward from the star center. This nuclear reaction creates energy that heats the star and makes it shine. Which one of these relates to main idea 1? Go ahead and quickly copy that right there. Which supporting detail relates to main idea 1? Go ahead and pause me. Okay, supernovae make important elements. Which one relates to that one? Elements, like I said, from the periodic table. Like, ooh, just kidding. Like those right there. Okay, hopeless, just kidding. So those elements that the text stated, like hydrogen, helium, oxygen, iron, lithium, the text went into how we needed oxygen and iron, right? And how iron, they thought, made up most of the universe. Or most of the iron in the universe was made from supernova explosions. My bad. So it's going to be this one that goes along with main idea 1. This is a supporting detail that goes along with this. So you should have that written down right there. You can pause me to write it down. Main idea 2, only some stars will become supernovae. Which one relates to that? Which star did they say will not become a supernovae? Supernovae is something, or supernova is a star that explodes. Oh my gosh. Oh my goodness. The sun will never explode. Boom. And you're finished. Have a good night. I know your brain is fried. You've turned into supernova. Okay. Hope you got them right, and I know this one was a struggle. Take care. I love you very much, and I'll see you tomorrow.